written. I'm just testing it to make sure that it works because I don't want anything like what happened last time to happen again. That kind of sucked. So um, once I test it and make sure that it's working properly, it will be posted by Tuesday at the absolute latest. You can probably already guess what it's going to be, right? I'm going to ask you to create a high-level state machine and write the code for it. So, that's what we're going to do today as well, is practice creating these high-level state machines and looking at VHDL code for them, or even writing VHDL code for them. That's probably what we're going to do for a big portion of next week as well. I promise eventually we will do something different, but based off of what I've heard from talking to other students about the course material, I think we really just need to keep drilling on this until we get it, because this is a pretty important topic, especially as it relates to this last section. So we're just going to keep practicing creating high-level state machines and writing VHDL code until we are all experts at it. Sound good? Any questions about logistical stuff that's coming up? Okay. Fantastic. So last time we saw how to create a high-level state machine for button debouncing. Right. This time we're going to switch our attention to the knob. So there's a knob that we can turn on the FPGA, right? So let's talk about how this knob actually works. The way that it works is actually comprised of two buttons. So as I turn the knob, consider what happens. If I turn it one direction, this one will go down first, and then this one will go down second. Right? If I turn it the other direction, then this one goes down first, and this one goes down second. Right? So I can tell which direction this knob is turning, right, by the order that those buttons get pressed down. So what are my inputs? What are my outputs? Let's get that squared away before I task you with creating a high-level state machine. Right? My inputs are the two buttons, A and B. A and B, we'll call them. We can say that A is on the left and B is on the right. Right? Just be consistent about it. Those are my inputs. Those are the only inputs I have. That's it. That's all I got. The outputs are what? I have a tick. So the tick is going to go high for one clock cycle whenever I see that both buttons have been pushed down. Right? Whenever I turn the knob a little bit and it pushes those buttons down, that's going to be one thing. And then I have a second output called clockwise. If it's high, that means I've turned the knob clockwise. Think about what that means, how I can tell. If it's low, that means that this tick represents a counterclockwise knob turn, right? Because I want to do different things based on the direction that it's actually being turned. So your task is now to create a high-level state machine that can represent this behavior. Think about what variables you might need. Think about what states you might need. Construct the transitions. We have the VHDL for this already, right? So I do want to go over the VHDL a little bit later as well. But see if you can come up with the high-level state machine first. While you're doing that, I'm going to pass back the exams, and we'll talk about that a little bit later on as well. All right. Yeah, it's like a little feel signal. It's like yeah, like if you want on this clock value, then yeah, it's going to stay clock. Oh, I think yeah, that should be right based on this. I know.
Yeah, wait, then you're inputting on.
Yeah, that's yeah, any of the applicable variables, a little better. Once the other, you go back.
Clockwise is variable.
Yeah.
There you are, David.
Yeah, it's that we needed separate expressions. Oh, right. So then we should make this a new where it just outputs then you should output clockwise on the moving transition.
Yeah, it should just be like A or B, and then whichever one happens, yeah.
It'd be like B slash A, sign bit is the most significant bit.
Yes, thank you.
Yeah.
So, yeah, Colin, okay, I'll get you.
So
What is that? What is that?
I just saw yours.
But actually, I think we just
Thanks. Hey, what's up, man?
Yeah, I think
Although, well, we're gonna.
I remember that one.
Yeah, here, start with those first.
I still have one more.
Okay, that's fine, just get it to me, as soon as you can.
I don't know. Well, I actually want to make the.
So that's Elizabeth Pro and Mike.
And actually, this might not work. It's just transition over on A.
Point,
A again.
Will.
And that wouldn't.
They're not in any order there. Sunny Shop.
I guess technically it's
Angelica.
I think we need to be first.
Andy Gannon. Andy. Brian Thompson. Catherine. Arvin. Andrew. David Patel.
Yeah, so you would just
Miles.
It's like, if it was A initially, then you have to be able to differentiate that. Like if it was started in B, that A or B, but I still have to know whether it was A or B. So you're saying you can start all this, right?
Oh, wait,
Jack,
John Duncan. Christian. Christian Alliance.
How do I tell them?
Peter Olson.
Margie Gomez,
Edward Lynn. Edward.
Pierce, Stacy,
Zach Greenberg.
Daniel Gray,
Zach Early. Grant Bowles.
Zach B.
Okay, that's all you need.
Alwen Zuber,
Fernando Rojo. All right, cool. You got left. Carlos Gonzalez. Adam Warner. Carter Journal.
Jack Romar,
Satang Tang.
Yeah, but we need to. Nothing will.
Linda Holland. Nolan. Heather Pan.
I think we're almost done.
no,
We'll find it.
William Lyon,
Oh, did he find it? Who needs an exam? Who didn't get their exam back? Kate?
I think my takeaway.
Anybody else not get their exam back yet?
Oh, yeah, yours.
Oh, you didn't get yours back yet?
but that's good. I got one by the
The TA. Because, you know,
What? Who is, that's not you?
Oh,
The other one, yeah. The other
I
one, yeah.
understand what I am.
Thanks, man.
I know, but like, what is it, like, when is it literally what?
Is it possible I mean, technically it's possible, but there's not much we can do if that happens. We have to assume that there's going to be at least one clock tick delay from the first to the second. There's not much we can do otherwise.
How does the FPGA handle it?
The FPGA doesn't handle it. The FPGA, if that actually happens, you'll notice that we turn the knob and nothing happens because it can't tell.
It's just that the clock on the FPGA
The clock on the FPGA is much faster than humans are, like ridiculously fast. So the odds of it happening are pretty slim.
I think it's 6 megahertz.
It's pretty slim for that to happen. It could happen theoretically. You wouldn't notice it very often.
Yeah.
I also don't know if you can have different outputs. Wait, oh yeah. Can you like for one transition? If you have like two different
I could be wrong, but I'm pretty sure I got taken up for the same thing twice.
Yeah.
So I did this, which is probably wrong, and then I wrote my VHDL based on this,
Okay.
and I got taken off 8 points twice.
Okay. Here, let's take a look at that one real quick.
I guess I only got taken off 7 points.
Why did they take those points though?
I think it's because it's wrong, but like,
Yeah.
it's right compared to my
Okay.
machine.
Right, and they should not have double counted that against you. I will do a regrade myself. And
Yeah. Let me look over
number 3, right?
Yes.
I will take care of it.
Based on number 1, I guess.
Yeah.
Thank you.
Yep.
Okay, so let's
Okay. Oh yeah, I got yours.
Sorry about that.
No problem. Not a problem.
Okay, so my S1 is
There you go. Okay.
Let's get the exam stuff out of the way first, since I know everybody wants to talk about the exam. The distribution on this exam was eerily similar to the last one. Like, they were almost identical. It really creeped me out. So that's a good thing, actually. I was pleased with the scores on the previous exam. I am pleased with the scores on this exam. The median was an 86, which means more than half of you got a B or higher. The most common grade was an A. Most common grade was an A on this exam. So I was really happy with the grades. You know, I think it was like 2/3 of the class got at least an A or a B. That's great. That's fantastic. So they were not curved, obviously. The grades were really, really good. The regrade policy is the same as it was last time. You got to get it cleared through me or the TA first. If they say you have a valid case, then they'll mark the problem that needs to be regraded and get it to me, and I will handle all of those personally. Hopefully that does not happen. There were not very many last time, so I hope there's not very many this time either. But please go over it. Let me know if you find anything. I'll stick around for a few minutes after class if you have any questions about that. One thing that I do want to mention that's kind of related to the exam, there was a significant number of students who did not do particularly well, and this may not apply to all the people in this room, but I've kind of decided that for this last section that I'm going to put more of an emphasis on the stuff that we do in class. Not that I'm going to stop doing the videos. I'm going to still make the videos. I'm still going to expect that you do the side book. But it may not be unusual for me to introduce a new concept in class for this last section. I think it's too tempting for some people to just not ever come. And, I mean, you've noticed probably that attendance on class days is significantly lower than attendance on exam days. That bothers me. I don't like that. So I'm going to dangle another carrot to try and get people to come to class. You know, I've looked into it, and the people who are struggling are most often the people who I don't see here. So people who I do see here did well in the exam for the most part, right? So I want to encourage that. So just be aware that that's kind of a shift that I'm making over the last section of the semester. Are there any questions for me right now about the exam or
If you have regrade questions, hold those to the end. Are there any other questions though about the exam? Yeah. Yes.
Is that for sure set on that final date? So my other question.
No, that is for sure going to be on the final exam date that's given. It is not a cumulative final exam though. It's just a regular, ordinary exam. That covers the last section. So basically, this stuff till the end of the semester is what we're going to see on there. But it will be on that date, yes. It will be on that date. That is set in stone, so you can plan your holiday travel plans around that particular date. Any other questions about the exam right now? Or can we talk about this problem? I'd like to talk about this problem. All right. So you guys need to help me out with this one. I want to talk about potential design for this. I imagine there are multiple possibilities here, right? So who can help me out? Who can, we know what our inputs and outputs are. I spotted you those, right? What do we have to remember? What do we have to remember in this high-level state machine? Yeah?
We only had one bit variable that indicates which switch was the first one to be pressed down.
Okay, so one bit variable that indicates which switch was the first to be pressed down. So how would it work if none of them are pressed down? What would it be?
The way that we designed our state machine
That's interesting. Doesn't matter. Okay.
doesn't matter. Also add another bit and just have easily be 0, 1, 1, 0, 1, 0.
Yeah, I'm going to do it that way only because I know that's how the VHDL works out. I am curious about your design, though. I would like to maybe take a look at that a little bit later on. But yes, we do need to remember the previous button configuration, right? If we don't remember the previous configuration of the button somehow, then we're not going to be able to tell which direction we're moving in. So that's something we need to remember. How are we going to remember that? What are our options in terms of remembering that value? We've got two choices, right? Yeah. Could be either a state or a variable. What did you guys pick? Pick a variable, or did you pick to do it in states? Variable? Most people I'm hearing variable. I hear a couple of people say states. Okay. I mean, neither one is better than the other necessarily, right? They're just different outcomes. I did hear more people say variable, so I'm going to stick with variable. Again, I also know that the VHDL treats it as a variable, so we're going to treat that as a variable in this case. So with that idea, what do we have? So we have this variable, we'll call it, I don't know, previous button, right? It's a 2-bit value that indicates the previous configuration of the buttons. So it could be 0, 0 if they're not pressed at all, or 1, 0, or 0, 1 if one of them is pressed, or 1, 1 if they're both pressed, right? Okay, so with that in mind, what states might we have in this particular case? Somebody help me out with that? What states are we going to have? Yes?
We just use moving and not moving.
Moving and not moving. Okay, let's think about that for a second. Moving, not moving. And you had a 2-bit variable, right, for the previous button press? Okay. Let's try it out then. So we've got two states, moving and not moving. We've got this variable, right, to deal with. So I guess we'll assume not moving is our start state. That seems like a pretty safe assumption, right? What about the other transitions? That's where things get a little more complicated. So what transitions do we need to make this work? Yeah?
Well, we had it go from not moving to moving if A or B are high, and then your free button will store A, B, basically.
If A or B goes high.
And then we started moving.
So you're assuming that it's 0, 0 here?
Yeah. I guess that,
Yeah, I mean, not moving could be any configuration, right? Not moving could be any possible configuration. I'm not saying that it's wrong necessarily. Maybe the names are just maybe need to be tweaked a little. Let's keep going though. Let's keep going with this. So, how did you write out this transition? You said if A or B changes, then
yeah.
okay.
Or
Could we compare the previous button state to the current button state, right? Is that kind of how it works? So, you know, if both buttons together are not equal to the previous buttons, we'll take this transition, right? If both of them are not equal, then we'll take this transition. Do we need to do anything else? Do we need any actions on this transition? Yeah. Question?
I'm not looking at what is stored in the previous button.
I'm sorry?
What is stored in the previous button?
So consider we're going to be reading the buttons every single clock tick, right? So previous button is going to be whatever the value was the previous clock cycle, so that we can compare that against what the button presses are in this clock cycle to see if they've changed. Does that make sense? So one clock cycle, they might be 0, 0 like they are here. The next clock cycle, it might be 0, 1, indicating that this button has been pressed. And so we know that we're moving, right, in a clockwise direction.
Oh, so this is like previous inputs.
Exactly. But we need to know that information. If we don't know where we were in the past, we cannot possibly detect what direction we're moving in, or if anything's happened at all, right? If anything's happened at all.
Okay, so it's 2 bits like A.
It's 2 bits, yep, 2 bits. So I'm using this to refer to the current button presses. AB is the current. Where are we at right now? And this is where were we at last time. If they're not equal, then something's happened, and we need to figure out what that is, right? Figure out what exactly is happening. Everybody with me? Everybody on the same page? So what else do we need then in this case? Nope, you said no actions. We don't need to take any actions here necessarily. We're just good. Okay, what other transitions do we need then? Yeah, need some other transitions, I assume. Somebody help me out. I mean, eventually we're going to have to go back, I assume, right? What does that look like? Maybe if they're the same. If they're the same as they were previously, then we'll just hang out here. So AB is equal to previous button press. And there's probably a self loop here, I imagine, with the same, right? As long as they're not changing, then we're just going to hang out. We haven't set any outputs yet, though, right? That's a pretty glaring omission. Yeah.
On the first transition, could you technically, like, if when you started it not moving, if you already had A pressed, and then when you transition to moving, if that now pressed B, could your output then be clockwise?
It could be. It could be. Absolutely. Absolutely could be. Are we equipped to handle that? We don't really know what A, B, and previous button, we don't know what the values are. The only thing that we've said is that they're not equivalent. Could we actually inspect actual values? Sure, we could do that. I think we might need more states, though, if we head in that direction. Do you agree that we don't have enough to do that with 2 states, if that's what we try to do? If we actually look at actual values, which is actually a closer representation of what the code does, right?
We just need more complicated transitions.
Or we just need more complicated transitions. Yeah, we could.
Some type of variable.
We could include some more stuff on these transitions. It's a trade-off, though, right? I don't like my transitions to be crazy complicated, because then what's the point of having a high-level state machine if I just make everything in 2 states and write a whole chunk of VHDL code for each transition? That's kind of defeating the purpose a little bit. But I agree, we could certainly do that. That is an option. You know, I kind of like this idea of having multiple states. In fact, one thing we haven't discussed is, should this be a Mealy machine or a Moore machine, right? Should this be a Mealy machine or a Moore machine, or does it matter? It could be either, probably. What did you guys make yours, Mealy or Moore? Mealy? That's fine, that's fine. So I actually like the idea of potentially having it such that, here's kind of how I envision. Well, maybe I shouldn't erase this. Let me just start a new one. Here's kind of how I envision this problem. Here's our start state, right? Call it waiting. We can have one condition that's going to come over here to a state that we call clockwise. We've got another one that could come over here to, counterclockwise. And if we make it to either one of these states, then we just go ahead and set the appropriate outputs, right? Tick is going to go high. Tick is going to go high for 1 clock cycle. So here we would say tick equals 1, and clockwise would then have to go to 0. And then this would be the same thing. Tick goes high, and clockwise goes 1. So I didn't label these transitions. That's something that we need to discuss, right? But I also need to go back as well at some point. So I've got 2 transitions going outwards. What are these transitions going to look like? What am I going to put on these transitions, going from the wait state to counterclockwise or clockwise? What am I going to put there? So if I'm going counterclockwise, that means that, for example, my previous state would be 1, 0, and my current button state would be 1, 1. Right? So I could say something like this: previous button equals 1, 0, and A, B, my current buttons equal 1, 1. That's going to send me to the counterclockwise state. I set my outputs appropriately. Okay? Set my outputs appropriately. And then I could come up with a similar transition here, right? What would that transition look like for going clockwise? Be a similar thing, right? I'd say 0, 1 to 1, 1 might work, right? So it'd be the same thing. And AB equals 1. Okay? So that takes care of those 2 transitions. We're not done yet. How do I transition back? How do I transition back? I always transition back right away, right? Because I only want this tick to be high for 1 clock cycle. I want this tick to be high for 1 clock cycle. When does it go low again? Here, right? It's going to be low here. Tick equals 0. Do I need to do anything with clockwise or counterclockwise, or with the clockwise signal in this state? No, I just leave it to whatever it was before, right? Because we can see that just stays constant. Stays constant. Yeah.
Would you want to initialize it somehow, or?
Yeah, you could do that on the reset if you wanted to,
But it
right?
doesn't matter because you're only going to have a clockwise tick goes down.
That's true. You're not even going to touch clockwise unless the tick is going on. Yeah.
Is clockwise output or a variable?
It's an output. It is an output. Yep. What else am I missing? Am I missing anything else? Do you think this is good? I'm not saying this is the only way to do it. I'm not saying this is the best way to do it. I'm saying this is a way to do it. Yeah.
Wouldn't you need to store the previous button somewhere?
So that's kind of implied all the time, right? I guess there's sort of a self-transition here for every other combination of previous button and AB. So if it's not either of these 2, then we're just going to hang out, right, in the same state and record, right, previous button is going to get stored with AB. That happens every single clock tick, right? That happens the whole time. That happens no matter what. Right? So, yeah, I think we're pretty good. I think this is pretty good. Again, not the only way to do this. I believe that some of you have probably come up with some alternative methods, and that's great. That is excellent. This is just one proposal. Are there any questions? I'd like to take a look at the code. So we actually have the code for this already. Let me open up Xilinx so that we can take a peek. And see what the code does. Come on, let's go. Come on, Xilinx. Come on. All right, cool. So we're in the knob interface. I do want to give you a couple of warnings about this VHDL that we're about to take a look at. There is a VHDL construct in here that we haven't seen before, right? We haven't actually seen before. So I'll mention that in a little bit. This also does a bit more than what we've defined here because I left off some of the information that I gave to you at the beginning to make the problem a little bit simpler. We'll talk about that as well. So here's our inputs. Knob SIGs, those are going to be the buttons, right? The two buttons coming in from the knob. Tick, that's our output. Clockwise is our output. Delta is, if I'm using this knob to increment or decrement the number, delta is how much do I increment or decrement that number every time I turn the knob. That's what delta represents. I omitted that, right? We did not include delta as part of our high-level staging. Yes, question? You've already got it. You used it for lab 2 and lab 3. Oh, so it's in the file that you downloaded. Yep. Yep, the knob interface.vhd file. That's what I'm looking at. Yep, absolutely. So here's another piece that I kind of left out, although it should hopefully make sense. Those are buttons that we're talking about, right? We talked last time about a debounce button. What does it mean to debounce a button? Why do we do that? Yeah. Exactly. So we're going to debounce those buttons just like we would debounce any other buttons, right? So here's the VHDL to do that. We can use the same debouncer code that we talked about last time. It's the exact same code. We just create a new component for it, right? Component debouncer. The exact same thing that we're using, right, before. So there's nothing special there. There's no magic there. Here we see some signals. Again, this is another example of we have this high-level state machine, but do you see any states? We don't have any states. We don't need any states. We don't need any states to actually do this. How do we know what state we're in? What's determining that in this scenario? We've got clockwise and counterclockwise to help us out to some extent, and also tick, right? The outputs are determined by the states. So if we really want to know what state we're in, we can just look at the outputs, right? But really the buttons and previous buttons is what determine what state we're in. So we don't need explicit states all the time, right? That doesn't mean that this isn't helpful. That doesn't mean we shouldn't do this. We just don't necessarily need to code it up that way every single time if we don't need to. So we've got, here's our current buttons. Here's our previous buttons. So the previous button presses. That's part of our high-level state machine. Rotate and previous rotate, I believe, are the same things actually as button and previous button. We'll see that down here. So they're using, oh, I'm sorry, I take that back. Button and previous button, you can actually push the knob down. So for all the gamers out there, like the joysticks, you can push the joysticks in. It's the same concept, but with the knob. That's what the button, previous button represents. We didn't use that. We did not incorporate that. So actually, it probably would have been better if I would have called it rotate and previous rotate. That's what we have up here on the board. Rotate and previous rotate. Sorry about that confusion. But here we have rotate, right, being debounced. And then take a look at what we have. Ah, yes. I looked into this from last time because I gave a crappy answer last time somebody asked me this question. We set previous rotate to be rotate right away, and then we compare the two against each other, which seems really odd, right? We saw that last time too with the button debouncing. How does it make sense to set previous rotate equal to rotate, and then how would they ever be different here, right, is the question. How would they ever be two different values? Well, consider the way that the process works. It is sequential. It does operate things in sequential, but the values don't update until the very end. The actual values themselves do not update until the very end. There's one exception to that. Anybody know what the exception is? It updates right away. What kinds of values are these? If I had to call them something, I'd say I created a bunch of blank to help me out with this process. Signals. These are signals. Do we have something else we can use? Variables. So if I set a variable, that value is in there right away, right? If I set a signal, that signal does not get updated until after everything else, at the very end of the process, after everything else. So that's why saying something like this is okay. We're actually just queuing this up to happen in the future. Does that make sense? I know it's confusing. It's a little odd, especially compared to other programming languages, but that's how it works. That's how we can write something like that and not sound totally crazy. So we capture our previous rotation. Here's our reset logic, right? We see clockwise is actually set to be true when we reset it. That was kind of an odd choice. I'm not sure it really matters all that much. Then we check to see what the values are. So they checked different values. Okay, does it really matter? If I see both buttons are high and then I see that the button B has been pushed down, right? I know what direction I'm turning the thing. I know what direction it's going. Looks like we might have gotten the directions backwards, though. Might have gotten the directions backwards. Because clockwise. This to me looks counterclockwise, right? 1, 0, 1, 1. That looks counterclockwise to me. And this looks like it should be clockwise, but it's switched. I'm sure there's a good reason for that. We probably just have the buttons labeled in the button A must be on the right, and button B must be on the left. Just got the buttons flipped. But otherwise, it's the same thing, right? If I detect that the previous value is this and the current value is this, then set tick to high and set my clockwise value, right? Same thing for counterclockwise, right? Excuse me. This logic down here is not something that I asked you to create. But what does it do? If I push the knob in, if I push the knob down, instead of changing the rightmost number, it scoots over and changes, I think, 4 digits. So it allows you to change. It allows you to make larger changes, so I don't have to turn it to get to really large numbers. That's all it's doing. So you can see that it accomplishes this by changing this difference variable. But again, we did not incorporate that into our high-level state machine, so I'm not too terribly concerned about that process. In fact, I think we covered everything that we needed to. Are there any questions about this? Any questions? Do you see how the VHDL kind of matches up with the? Yes.
So the basic strategy, then kind of just using this as almost like a map to write your kind of like if or else statements, really.
Think about it. Yeah, sure. One way to think about it is this way. I can write every computer program that I want as a flowchart, right? That's kind of what we're doing here is flowcharting. Flowcharting our program and then writing it out. It's very much useful if you want to actually create the states in your code and use the states that way, right? That's great, but you don't have to. It can still just be kind of a guideline. Yeah. So if you get a chance, take a look at this code with the buttons and see if you can determine how it works. I'm not too concerned about it right now, but take a look at it. And if you have any questions, I'd be happy to answer them. What I'm more concerned about is this rotation part, right? That's what we did on the board. Any other questions before we try another one? Should have time for at least one more. Okay. The next one. So this is going to be a serial application, right? So we talked about the difference between serial and parallel values. So we're reading in a binary value 1 bit at a time, and we want to count when we see consecutive ones. We want to count it. We want to count that. And then the output of this is going to be the length of the longest string of consecutive ones that we've seen. So if I count another list of consecutive ones that's longer than the one that I saw previously, I need to update the length that's coming out of this. Right? You can assume that the length is arbitrarily capped at a certain value that it can't go to infinity. Right? You can make that assumption. Just choose a cap for it. I don't really care what it is. Other than that, you should be good. For this one, construct the high-level state machine, and then also write the VHDL as well for it once you have the high-level state machine. take a few minutes. We'll be around if you have questions, and we'll talk about it in a little bit.
How did you choose between this one is the previous one.
Right, and then like, but it's still like, there's still a whole
Oh, this is this. Yes.
Right, if you wanted to, well, actually, I mean, this is in
Yes, that's right.
There might be a longer one to come. We can't do it.
Got it. Oh, so we know what the code.
We don't know that. We just have to output the length of the longest one they can see. There might be a longer one coming, but we'll deal with that when we get there.
I think it's in the same class cycle.
Oh, that's for 361.
That makes sense.
Yeah, of course it makes sense, but it's just, it's actually a lot simpler than my
Oh, no, see, we have the current build, and the one with like the current thing that is counting. Oh, okay. I see, which is the highest. But actually,
I guess it should go in that same.
Yeah, I mean, there's no point in doing this unless you implement a council. Like when you're just sitting over here.
Yeah.
But I thought it was current. Okay, you're used to the so it's okay.
Yeah, but
I'm like in between.
we can use it as proof, I guess.
You say it.
Sorry. We say like in this room, you know, comparing it
It's more like one teacher called it like one day.
Yes.
It will only be on air.
No,
I don't even think we need an app. We just need to sell that picture as an icon. You don't even need code. It'll be perfect. It's got voice.
Yeah.
Steve Jobs.
You heard about the app? Oh, that's okay. That's add another variable.
What's going on with companies do now? They really smart these apps.
It might be easier to do all that.
You might even do it in app purchases.
Yeah, bring it to,
But if you buy an app, you have to the way companies do things now, a lot of them use like that, electronic like that. Not the app is free.
You don't need to think about it.
Whatever, and then you can buy it. Right. Well, it's like, what's funny though is they allow me to have like well, yeah. But then they also, what's smart though is not to hide the device.
Wait, so what did you say? Is you got two ways?
The obvious is
How do we make it?
Yeah, but not across like mobile banking or anything like that. Yeah, like the actual banking, and also I want. Oh, you're talking about like
oh, yeah.
Yeah.
Oh,
Yeah.
so it's like it's like an integrator.
Yeah. What it is whenever I have a text, like just normal texting, I have the option to change what happens, change my keyboard to there, and then I can get to my goal.
question from IKEA.
Yeah, it's wonderful. I don't know how I would because now every single one of my passwords is 28 random.
Okay, so it's okay with that.
With the exception of my watching password, because I actually have to have that. But that one's still random stuff. It's just they happen to be named so much. You can like, it's like five little segments of letters that are all actually hyphened together into one gigantic thing. So you remember a couple different things. And where the capitals go.
A lot of companies got smart and realized that we were like secure, like obviously not secure. And what is the best password yeah, that is like
That's exactly what so like it never yeah, I mean, this will say
well, nobody's gonna know. You know, we're gonna know that you're not gonna app on a file.
I mean, I'm willing to read.
That's why it's silly that we realize that someone says like, oh, we're not gonna go
How do you do it?
it's surplus, you're not gonna see it like that.
You can make it a variable. Yeah, variable update.
Numbers is happening. Just I mean, I kind of do that with my computer.
Okay, let's talk about this problem. So I think our inputs and outputs are pretty straightforward, right? Our input's going to be just a single bit. It's either going to be a 0 or a 1. That's what I'm going to be counting, right? I'm going to be counting ones. So our output is going to be a length. What's the length of the longest string of ones that I've seen so far? So what do I have to remember? What does this thing have to remember? Who can help me out here? Yeah.
The like previous longest string ones or consecutive string of ones that are found.
Previous longest
Yeah.
or longest, right? What's the longest? What's the longest string of ones that is found? It needs to remember that, right? So longest run, we'll call it. What else do I need to remember? Yeah, in the back. The current, right? So current run. And I guess I might have given this away. Are these going to be variables or states? They're definitely going to be variables, right? These could have a wide range of values. I do not want to create a whole bajillion number of states. That's usually not a good thing. Yeah. You could, yes. You could, in fact, use longest run as the output. The issue there, well, is there an issue with that? Let me cheat real quick and look at my solution. Yeah. In my solution, actually, I do have these two variables. I'm trying to think if there's a good justification for why. Yeah. Do you have a?
So our thing is, if you have longest run just be the output, we don't update the longest run every time we move it. Because we don't want to end up in a state where we have, say, a string of 4 ones, a 0, and then 6 ones. We don't want to output 1, 2, 3, because as we go through them, because that is giving information that just isn't useful, and it reduces the quality of other information we give out. Because by knowing the fact that there's a string of like 4, you know that within that string there are 2 strings, 1, 3. But when you're having the machine output it, it just.
So I guess I think I kind of understand what you're saying. Here's what I have to say on the matter, right? When I do a signal assignment, right? If I have a signal called output, and I set it up to be, current run, for example, and then I change current run, does output change? If I hook these up and then I change the value of this, does this change? Yes. Why? This is a wire in a circuit, right? This is a physical connection that's being made. So what happens then if let's say I don't use this, at some point I'm going to have to say the output is whatever the current run is, whenever I find a long run of ones, right? I'm going to have to say something like this, and then I'm going to have to eventually reset this back to 0. What's that going to do to the output? It's going to reset it back to 0. So I'm going to lose the information, right? So we do need 2 variables, I think. Yes? But when I say this, I'm actually fusing these two together. I'm fusing these things together. So the next time around, whenever this changes, this is also going to get hit. Yes?
So how do you set longest run? Because what I was doing is like if current run is bigger than longest run, then longest run is current run. But if since they're wires, like how would I even set that?
Yes. So you would have to set it.
I can do it, I guess, like right when it's greater.
So I guess.
You can have like a longest run plus plus.
I guess we should be. You know what? Instead of talking about theoreticals, why don't we actually? I was planning to code this up. So why don't we just code it up later and see what happens? Why don't we do that? Let's get this down first. I'm going to do it with 2 variables because that's the solution that I have. But somebody please give me a heads up when we actually start to code this thing. I will try it with 1 variable and see if we can get it to work. How's that? Yeah.
On the note of being able to set longest run, when you set it under an if, it isn't equivalent to just wiring it straight in.
I
There's the
believe
end
you're,
wire.
yeah, I believe you're correct.
Yeah.
Because we're doing it in the context of a flip-flop, right, register, right?
Yeah.
So I agree with you there. We will try it both ways. We will solve it once and for all by coding it up in just a little bit, assuming we have time. If we run out of time, we'll do it next time. I promise. I promise, I promise, I promise. Let's get a state machine first. Let's get a state machine going first. Who can help me out with the state machine? What states do we need? Yeah.
I have a weight state and a count state.
Weight state and account state. Okay. Weights. Count. Okay.
And weight is your initial state.
Weight is my initial state. Okay, so I start here and then what?
When you see like my input is called A, like A equals 1,
Uh-huh.
then you go to the count state, and you stay in the count state as long as A equals 1.
Right.
And then when A equals 0, you're going to go back to the weight state.
And as long as it's 0, we just chill, right?
Yeah. And then when you move from weight to count, you set your count, like your count variable. Oh, you call it current.
I called it current
Current
run,
run,
yeah.
sorry. You set current run equals to 1.
Equals 1. Okay, I'm with you.
And
And then we increment
yeah,
here.
then increment every time.
Right. So this is when it's 1, and then we say current run plus plus. Okay, I guess, so eventually we'll have to reset current run to be 0, right? That's probably going to happen here
On the way back.
on the way back. So current equals 0, right? And then the only thing we're missing is longest run. So when do we take care of that? Yeah.
Should probably check for that when you're transitioning back to the base.
Check for that when we transition back to the weight state. Yeah, we could do that. So we could do that here.
Yeah, before you set it.
However, I mean, so this is going to be 0 at first. And as soon as we get here, it should now be 1, right? Yeah.
So I was checking it every time it transitions back to the count state and it transitions back to the weight state. So every time count is implemented, I check to make sure that the current run is, sorry, I call my count. Every time current run is implemented, I check if current run was greater than longest run,
Yes.
and if so, then longest run was, I don't know how to say
Yeah.
it.
I think it only needs to happen here and here. I don't think it needs to happen here. I'm not sure that it will hurt anything. I think it's just extra. Does that make sense?
Yes.
It only needs to happen here and here. So we just need to have an if that says if current is greater than longest, then longest is current.
Then don't we have a problem with longest being current, as you just said?
So longest is not the output, and actually we're gonna talk about that more when we get to the coding in just a little bit, right? So this same code, I'm not going to rewrite this whole thing, but it would also have to go here too, right? The same if statement that we just put would have to go here as well in order for us to maintain it. And then we also need to, at all times, say, output is set to longest, right? Because longest is not actually our output in this case, it's just a variable, so we need to physically connect that. Yes?
So that whole wire connection thing you're talking about, that doesn't work for variables? Like, why doesn't longest run change with current changes?
Well, this isn't VHDL code for starters. We haven't written any VHDL code yet. We're going to do that a little bit, right? So I think talking about coding when we're just looking at the state machine makes things more confusing than it helps, because the code is going to end up being different than this. We're going to use this as a blueprint, right? We're going to try and make the code as big as possible, but as close to this as possible. But we have some other things involved. Namely, we have to remember these are registers. We have to remember we have if statements involved as well, which Eric was pointing out changes things a little bit too. So let's talk about writing the code. Before we do, are there any questions on this? Yes?
Why do we need the count state? With this, those two transitions are exactly the same. So couldn't you just have the weight state with those two transitions both in self-transition?
Good question. Could we get rid of this state entirely and just do this one? What do you guys think? Yeah.
you know, because the count state denotes that the last thing that you saw was a 1, while await denotes the last thing you saw was a 0.
Sure. So I agree with that. I mean, can we give a practical reason? What would break if we condense them down to one state? Yeah. How do we reset this if we condense it down to one state? I'm not sure.
Isn't that just any time your input goes low, you just set current to 0? Why would you
Yeah, sure. I see what you're saying.
Count's not actually tracking anything really, it's your inputs that are tracking the output.
I see what you're saying. Yeah,
We just did it with one state.
sure. So you're saying just do this and that problem is solved.
Yeah, current 0, and you still just output.
Okay. I think that would work, yeah. It would. Yeah. No, I agree. These transitions are the same, these transitions are the same. Why do we even need this guy in the first place? Yep. Minimization, right? These are both going to the same place, these are both going to the same place. We don't need them. We can minimize it to one state. One state. Seems crazy, right? Let's talk about code. I want to write this out in code. Unfortunately, we are running out of time, so we may have to do a to be continued here. But that's okay. We'll deal with that. New source. We are going to call it max runner. Did I make that the right thing? I didn't, did I? It needs to be a VHDL module. There we go. Let me set my ports. So we've got clock coming in. We've got our bit that's coming in. Well, we've got reset coming in. I'm going to call my input A. And then going out, we've got results. I'm going to limit our length to be 4 bits. So it's a bus. We'll call it 4 bits going out. And then I think that's it. Yes, that's it. Go ahead and hit next, finish. Okay. There's our beautiful entity. It looks good to me, right? Looks good to me. Here's our architecture. So what do I need? Somebody help me out here. What do I need to start typing in? Yeah. We need our signals, right? We need these guys. We need those signals. So I'm going to keep those at 4 bits as well, since our output is 4 bits. The number of bits isn't particularly important, so I'll call them current run and longest run as standard logic vector 3 down to 0. Do I need anything else in this area before I move down to the beginning? Questions? You're stretching. Stretching. All right. What am I going to put down here then in this section? Who can help me out? Yeah. We need a process. What's the sensitivity list of that process going to be? Clock. Perfect. Okay. What comes next? If rising edge. If rising edge clock, then what do I usually do next? We're going to check our reset. So if reset equals 1, then what do we do if reset's 1? What do we need to do? We're just going to reset everything to 0. So longest run is set to all zeros. And current run is also reset to, oh, I made a typo there, didn't I? There we go. All zeros. Okay. Else if what? Depends on A. Yeah, so what am I going to check? If A is what? We only got 2 choices. Which one do you want to do? 1 or 0? Let's do 1. All right, let's do 1. If A is 1, what needs to happen? A is 1, what needs to happen? Current run plus plus. Can we actually, I don't think we can actually say plus plus. We'll say current run is current run plus 1. What else do I need? I know I use plus plus up here as shorthand, but I don't think we can actually do that. Anything else? We can move on. Yeah. Yep. So we need to see if we are, if we have found the largest run, right? We need to see if we found the largest run or not. And so let's be a little careful about this. What was, so this is what we wrote on the board, right? Let's write this out and see. If current run is greater than longest run, then we want, longest run to be current run. And if. So let's talk about this for a second, right? Let's talk about this. Remember, as we go through a process, it does evaluate things sequentially, but when do things actually get updated? At the very end. At the very end. So what does it mean for current run to be greater than longest run? That means that current run was longer than greatest run the last clock cycle, right? The previous clock cycle, not this current clock cycle. So what does that actually mean? Why does that matter? Why am I talking about this? Because consider we just incremented this by 1, so it's actually 2 higher. It's not just 1 higher, it's actually 2 higher. We missed the boat. You see that? We missed it. We would have a gap. Do you understand where that gap comes from? So what are we interested in instead? Not if it's greater than, but like I lost them. What? I heard somebody say something. We're really interested in just equal. We're really interested in just equal. Think about what this means, right? If they are equal, that means I'm about to add 1 to my current run. So if they're equal now, and I'm about to add 1 to it, that means that I've technically found a longer one, right? Again, it's based on how processes work. So here, right, I don't just want to say current run is set to longest run. I actually want to say current run plus 1 here, right? Do you understand why saying greater than isn't going to cut it? It would be fine eventually, but we would be a cycle too late. There'd be a gap. We'd miss one, right? This way, it's going to work because we're checking the current value of the register against the other current value of the register. We know we're about to update the register, so we better do this now. Better do this now instead of waiting another clock cycle until it's truly greater than to do it, because otherwise we have a gap there. It's a pretty subtle distinction, yeah.
So you know this in the process, the value of the current run in all of those cases of current run is the previous value?
It's whatever's currently stored in the register. So this current run plus 1 is going to happen, but not until we're done with the entire process. When we're done with the whole process is when we update that value.
So when you update longest run and current run at the same time, if they were equal during that run, they're both adding just 1.
That's correct. Yes, that is correct. They are both going to be 1 higher after this. That's correct. That's correct. And they're going to be equal, right? They're going to be equal to one another the next time around too. So if we see another one, what's going to happen? Well, they're both going to get updated again, right? But that's okay, because that's the correct thing to do. They should both be updated. Yeah.
So what happens when you don't see another one when it drops down to 0?
Yeah, so we haven't coded that yet. We need to do that, though. We need to do that. So let's take care of it. I can just say else here. What happens when we go to 0? What do we need to do? This is an implied a equals 0. Oops, 0, right? That's what's implied by that else. So what do we need to do? Reset our current run value to all zeros. Anything else? I don't think so. I think we're actually good. So just end if. There is one thing that we're missing. Does anybody know what it is? Outputs. What should our output be? longest run. So we need to actually connect that up, right? We need to say output longest run. And what is the name of the architecture? I don't even remember. Behavioral. Okay. Oh, it's already there. Okay, cool. Don't need it.
You'll get one syntax error because the HDL doesn't understand what else if is. It's ELS if,
Oh, thank you.
which is so confusing.
Yeah.
Why that was ever the decision.
Yep. Okay. You should write them a strongly worded letter. So this should do it. Unfortunately, we're out of time, so I don't have enough time to prove it to you. But next time, I will show you a test bench of this. I'll actually post this code online. You're welcome to test it yourself if you want. And if you want to try eliminating a variable, I would encourage you to do that too. Questions? I see 2 questions. Go ahead.
When does this stop? Like,
It doesn't stop until we trigger the reset. As soon as we trigger reset, it just goes back to the beginning. Otherwise, it's just going to keep churning forever. Yeah. Is that your question too, or?
No, I think I might figure out.
Okay. Cool.
I'm curious about like if this thing's only work.
Oh,
Actually,
Yeah.
probably
We can't make a variable
No, it's just this other. Yeah.
reset or have like a.
So what is going to happen is the value is going
Oh, I already
Come talk to me about it. Show me what you need regraded. Is that what you need to talk to me about? Let me turn this off real quick.